Welcome to the Engineering Update. I'm digital editor Jason Lundberg, and in this week's episode, NASA's 10-engine Tiltrotor drone using 3D printing to prevent a rare pediatric disease and eye tracking technology that improves the driver experience. At first glance, NASA's new 10-engine drone looks like someone Frankensteined together a C-130, V-22 Osprey, and a Harrier for good measure. So naturally dubbed it the GL-10 Greased Lightning.
What could be Greased Lightning?
Greased Lightning! We'll get some overhead lifter.
The Greased Lightning is a battery-powered diesel-electric hybrid with a 10-foot wingspan that includes 4 turboprop engines on each wing and 2 more on the tail. The vertical takeoff and landing aircraft uses a tilt-rotor design much like the V-22 Osprey, and like the Osprey, it can change its shape mid-air to switch from helicopter to airplane mode and back again. 3 throttle controls handle the engines in each wing and the 2 on the tail, and the prototype includes a maximum takeoff weight of 62 pounds. The full-scale version will feature a 20-foot wingspan with 2 diesel-electric generators at 8 horsepower apiece and the ability to loiter for up to 24 hours. But one thing won't change. Both versions are slated to be remotely piloted, and this could be a figurative glance into the military's crystal ball. In the future, we could see a number of stalwarts, like the Osprey, go unmanned. The Greased Lightning made its first tethered flight back in August 2014 and just recently tested its VTOL capabilities. Earlier this week, the GL-10 demonstrated its ability to take off like a helicopter, rotate its wings mid-air to fly like a conventional turboprop, and switch back to land vertically.
We've talked a lot about different uses for 3D printers, from pizza makers both on Earth and in space, to fashionable dresses, and even tiny reprints of our editorial director's head.
That's my face.
They printed my head!
But some of these most compelling stories come from the medical field. Things like 3D printed skulls or devices that can be printed to fit individual needs. Researchers at the University of Michigan have designed a 3D printed piece that is capable of preventing an infant's airway from collapsing due to a rare pediatric disease that affects 1 in 2,000 children. The disease weakens the tracheal walls and the bronchi, which carry air to and from the lungs. The weakened walls can cause the airway to collapse. The current treatment, aside from being constantly on a respirator requiring hospitalization and sedation, is to use a splint sutured to the airway to create more support. As with a lot of medical treatments, the pieces are expensive to create, plus they have to be changed in the event of growth or migration. However, according to Gizmodo, the team at Michigan have created a 3D printed polymer solution that is capable of growing with the child due to the unique splint they've designed that is open on one side. The splints are created using CT scans loaded into a program that measures 10 variables to create the perfect splint for each person. The other interesting thing the team noted is that the material used in the splint disintegrates after 3.5 years and costs just $10 to create. This timeline is crucial because once a child reaches 3 years of age, doctors generally assume they have enough structural strength to continue doing well. The team has successfully used the splint on 3 children via a special use exemptions, as they haven't been approved for a clinical trial. The next big step will be a clinical trial with 30 patients.
Back in January, Jaguar, Land Rover, and Intel partnered with Seeing Machines to develop eye tracking technology that could be used to prevent drowsy driving. Since then, they've come up with even more ideas for eye sensing tech that is useful in more day-to-day scenarios. One new use for the technology is the driver monitor system. Still in prototype, it monitors the driver's eye movements, even with sunglasses on, to detect distraction or drowsiness and trigger alerts if a situation arises. Integrated in the prototype, Seeing Machines use Intel's new Core i7 chips. Another use to aid drivers is monitoring and firing the rear wipers. Thanks to rain or wet roads, oftentimes when you glance in your mirror, there's a good chance the view through the back is obscured. Using this eye tracking tech when your eye moves towards the rear mirror, the car will automatically trigger the wipers to give an extra wipe, so your view is clear just at the moment you need to see through it. Working behind the scenes, eye tracking technology could definitely improve the driving experience. You will likely see the technology used on Land Rover machines, and it may even make its way into high-end Range Rovers in the not-too-distant future. That's all for this week's video. Be sure to check in on Facebook and Twitter and catch past episodes on ECNmag.com. For the ECN channel, I'm Janine Mooney, and thanks for watching.